In this lesson, we're going to look at similar figures. Now, quick review, we know that the ratios of corresponding sides on similar figures are proportional and corresponding angles are congruent. That's what it means to be similar. Now, we also learned that the ratio of the perimeters is equal to the ratio of the side lengths when figures are similar, and that the ratio of the areas is equal to the ratio of the side lengths squared. So let's look at what that means. I have two rectangles here, rectangle A, rectangle B. Rectangle A has a side length 4, rectangle B has a side length 6, and these two rectangles are similar. So because of that, we know the perimeter of A to B is the same as the ratio of the side lengths of A to B. Well, the perimeter of A to B then is equal to 4/6, since those are the corresponding sides. And this reduces to 2/3. So I don't know what the perimeter is, but I do know if I found the perimeter, its ratio of the perimeter of A to the perimeter of B would be 2:3 or 4:6. We can use the side length ratio to figure out the perimeter. So let's say that the perimeter of rectangle A was 20. If its perimeter is 20, then I want the perimeter of B. Well, the perimeter of A to the perimeter of B is equal to this ratio, 2:3, but it's also the ratio of their perimeters, so that would be 20 to whatever the perimeter of B is. I'm going to call that P. And from here I can cross multiply and go 2P equals 3 times 20, or 2P equals 60, or P, if I divide both sides by 2, is 30. So I know that the perimeter of B is 30 because I know that the perimeter of A is 20 and the ratio of their side lengths is 4:6. Now that is not entirely true of the areas. The areas are not proportional to the side lengths, but rather to the side lengths squared, and that's because instead of looking at a length, we're looking at an area. We're talking about a surface, so we're in 2 dimensions, we have to square that. And so the area of A to the area of B is equal to the 4/6 squared. Now I can still reduce that, so this is still the same as 2/3, but now I have to square it. And when I square that, that's 2/2 squared and 3/3 squared, which is 4, because 2 times 2 is 4, right? Square 9, because 2 times 2 is 4 and 3 times 3 is 9. Now we take that and we set it and we use it to find the areas. So the area of A to the area of B is the same as that side length ratio squared, or 4:9. And the area of A is 24. So 24 over area B, which I'm just going to call B, is equal to 4/9. And so I cross multiply. 24 times 9 equals 4 times B. 240 minus 24 is 216 equals 4B. Divide both sides by 4. We get 54 equals B. Now if we did everything right, our ratio should work out the same. So we started with area A 24, we just said area B is 54. We can divide both of these by 6. If I divide 24 by 6, I get 4. If I divide 54 by 6, I get 9. And so that 4:9 ratio is the same as this 4:9 ratio, which came from the side length squared. Remember, that was 2/3 squared. So we have to remember that the area of one similar figure compared to the area of another similar figure is equal to their lengths ratio squared. So length A squared over length B squared.